I have a couple of problems here from section 6.5, and they're kind of opposites of each other. This is a problem like number 46, and this one is like number 54. One of them they want you to expand, so what I call that is put it in compact form, from compact form to expanded form. So in other words, it's going to be a series of a lot of logs, and you have to apply some properties that we've learned in this course. And on this one, there are already multiple logs and you want to write it as a single log. So in other words, the answer to this one will look kind of like this one, and the answer to this one will look kind of like this one. So that's kind of what's going on. So this is problem 46 and 54. So let's do number 46 first. And there are a couple of rules, actually 3 rules that we talked about: the product rule, the quotient rule, and the power rule. And we're going to be actually using all 3 of these rules. Now, first of all, this is the log of the quotient x times the square root of x plus 4 over x minus 1 squared. And they're just saying x is greater than 1 just simply because you can't have log of negative numbers. You can't take log of something that's undefined. So they just put this as an indicator, that just to make sure that you know that x can't be just any number you want it to be. So for example, if x was 0, then you're going to have a problem. So it's got to be greater than 1. So that's just kind of extra information, which really is not needed to solve this problem. So the first thing I'm going to do is apply the quotient rule. The quotient rule says that the log of a quotient is the difference of the 2 logs. So you take the log of the numerator minus the log of the denominator. So it becomes the log of the numerator, which is x times the square root of x plus 4, minus the log of x minus 1 squared. So that's the first step. Now, so you already have multiple logs already, you see. So now this one is the log of x times the square root of x plus 4. So this is a product. So the product rule says that the log of the product of 2 things is the sum of those 2 logs. So in other words, the log of this product would be log of the first plus the log of the second. So this becomes the log of x plus the log of the square root, which we don't need the parentheses really, the square root of x plus 4 minus the log of x minus 1 squared. So we're almost done, except there's no more products, there's no more quotients, but there's some powers. There's actually 2 of them. You're like, well, there's only one. There's a power there. This one doesn't have a power other than 1. This one actually has a power also, but it's kind of hidden. It's the square root of x plus 4. So the square root of x plus 4 is the same thing as to the log of x plus 4 to the 1/2. So it's the same thing. So there is a power there. It's just a fractional exponent. And then the log of x comes down and minus the log of x minus 1 squared. So then the power rule says if you take the log of something to a power, then the power can be written as a factor. So in other words, the 2 can be written in front, the 1/2 can be put in the front of it. Now this one's other than 1, so if you put the 1 in the front, it really doesn't change anything anyway. So the final answer would be the log of x plus 1/2 times the log of x plus 4 minus 2 times the log of x minus 1. So that's as far as you can expand it as possible. A lot of people see this log of x minus 1 and want to do something with that, like change it to maybe log of x minus log of 1, or this one, the log of x plus the log of 4. You got to keep in mind there is no such thing as a sum rule, because if there was, you could do that, log of x plus the log of 4, but there is no such thing as a sum rule. There's a product rule, quotient rule, and the power rule. There is no sum rule and there is no difference rule. So since those rules don't exist, that is as far as you can expand it out. And that's it for number 46. Now, as far as 54, see how expanded 46 was out? Well, this one's expanded, but not quite as bad as that answer. So this one's actually a little bit more simplistic. This is the log of this plus the log of this. So now you're taking the sum of 2 logs. Now, just like a while ago, I was saying that this log of this product is the sum of these 2 logs. Similarly, if you have the sum of 2 logs, that would be the log of the product. So you're just kind of going backwards, back up the chart here. So the log of this plus the log of that would be the log of the product. So it becomes a log of the product of 1 over x minus 3 times 1 over x plus 2. And really, the only thing you can really do is just multiply those out, and you're pretty much done. So this is actually fairly simple. So log of 1 times 1 is 1, numerator times numerator, and denominator times denominator turns out to be x squared minus x minus 6. So you just FOIL x minus 3x plus 2 out, and I believe x squared minus x minus 6 is what that would become. And then close off that parentheses, and you got it as a single logarithm. So as you could tell, this one's got multiple logs. The final answer is a single log. This one here was a single logarithm, and then when you expand out to multiple logarithms, you're still using the same properties, the product, the quotient, and the power rules of logarithms, but you're just using them in reverse order. So, really, this one right here is probably the most usable. The number 46 is kind of a problem that you would use just to get practice with it. There's really no practicality when you'd want to do something like that. Usually when you're solving equations, you're going to have multiple logarithms in a single equation. Well, what you're going to want to do is write it as a single logarithm. So this is more practical. But when you're solving equations that have already one logarithm, you don't want to make it more worked out. That makes it worse. So this just gives you a kind of a practice of how to using the rules. So this is more practical for you. But anyway, this is 46 and this is 54 in section 6.5.